If I mess up, then I mess up. Who cares? Okay, here we have got an atom. On the inside of the atom, we've got the nucleus. On the outside of the atom, we have got the shells or the orbits, correct? We know these things. We can talk about radiation coming from the shells when we talk about EM radiation being released from electron shells when the electrons jump into higher orbits and then fall back down again. That's electromagnetic radiation. Not usually what we talk about when we're talking about nuclear radiation. Nuclear radiation comes from the nucleus, okay? Nuclear decay releases high energy particles. If I have got an atom with a nucleus that is high in energy, lots and lots of energy, the only way that my nucleus can remove that energy is by literally pushing it into the environment. The way that that happens, the way the energy is sent out into the environment, that's what we call radiation. There are 4 types: alpha, beta negative, beta positive, and gamma. You have to know these symbols, okay? Alpha, beta negative, beta positive, and gamma. They are the first 3 letters of the Greek alphabet. We'll start off with alpha radiation, spelled A-L-P-H-A, not A-L-F-A. A-L-P-H-A. You have got a large nucleus. Inside the large nucleus, we have got protons and we have got neutrons. If my nucleus wants to remove some energy from itself, then it will fire off an alpha particle. An alpha particle consists of 2 protons. What's the charge of a proton? Thank you, someone said positive. And 2 neutrons. What's the charge of a neutron? Neutral, okay. Do we see any electrons orbiting around this shell? We do, orbiting around this nucleus? We do not. However, there are 2 protons and there are 2 neutrons. The same as a molecule, an atom of helium. So helium has got two protons and 2 neutrons. So does the alpha particle. So another symbol that we can use for an alpha particle is a helium nucleus. Well, sorry, scrap that. Helium nucleus. Helium-2,4. It's an ion. What charge is on this ion? It's got 2 positives and it's got no electrons. What is the charge of this ion? It is 2 plus. Thank you to whoever said it. 2 plus. 2 protons, 2 neutrons, it's got a charge of 2 plus. You can see it either as an alpha symbol, an alpha, or you can see it like that, helium-2,4. You can also have beta radiation. Now beta radiation comes in 2 types, beta negative and beta positive. Beta negative radiation. When I have a neutron, my neutron consists of different types of charge carrying energy particles. A neutron can split up to form a little bundle of positive energy, and it can split up to form a little bundle of negative energy. Now the positive energy, when we talk about something being inside the nucleus and it's positive, what do we call that? Proton, right? So we're going to make a proton and we're going to make an electron. The electron will be fired out and that will be my radiation. The proton will stay inside the nucleus of whatever atom has undergone beta negative decay. So beta negative decay involves the breakdown of a neutron to release a high powered electron and leaves a proton behind. Beta positive decay, start off with a nucleus and inside the I'm going to take this back, pardon me if you don't mind. We're going to start off inside the nucleus. I'm going to start off with a proton. The proton is going to fire off a little bit of positive charge, but this is a weird kind of positive charge. It's like a positive electron, an E+. We call this a positron. Now because it's fired off of all of its positive charge out, we can think of it as having removed all of the positive charge, and what's left is neutral, a subatomic particle that is neutral. What do we call a subatomic particle that is neutral? A neutron. Okay, so we've got my positron fired out and we're left behind a neutron. So we can summarize this in saying that beta negative decay, we've got a neutron that splits up into a proton plus an electron, and the electron is fired off into whatever space we're talking about. Beta positive, we're going to start off with a proton that turns into a neutron plus a positron, an electron with positive charge. Okay? The final one that we're talking about now is gamma. gamma radiation you'll know as an EM wave. It's an electromagnetic wave, which means it has got no mass. It has got no charge, it has got no mass. It is a wave of energy. Here is the nucleus of my atom. The nucleus of my atom will send out a wave of electromagnetic energy. That electromagnetic energy is a very high frequency, which means it releases a lot of energy. It's the most energetic of all the EM waves. It has got no mass, it has got no charge, it has got no particular matter. So a quick summary then. Alpha, beta, beta, gamma. Alpha has got a mass of 4, it's got a charge of +1. Beta negative has got a mass that is negligible and has got a charge of -1. Beta positive has got a mass that is negligible and has got a charge of +1. Gamma has got both mass that is negligible and charge that is negligible. Yep. Oh gosh, you're right. Well spotted. I did that on purpose to confuse you. No, I didn't. That was just stupidity. Sorry. What do we have to know? We have to know about ionizing and penetrating. Ionization will happen when you've got a highly ionized radioactive particle. So alpha is the most ionizing. And it goes all the way down to gamma, which is the least ionizing. These are the same, okay? Beta negative, beta positive, we can say they've got the same amount of ionization. However, penetration goes the other way. Because there's no mass to a gamma wave, it is the most penetrating. And alpha is the least penetrating. Gamma particles can get through lead. Beta particles can get through aluminium. Alpha particles are stopped by paper. Summary.